Actually, hold on, give me 1 second. All right, we'll get started. So, welcome everyone to the first Vaughan School of AI meetup. I'm Nikita Verbe, and I've been selected as the dean for the Vaughan School of AI. So, a little bit about the Vaughan School of AI. So, what is it about? So, it's an initiative started by this actually one really famous YouTuber named Suraj, who has been providing a ton of great content online in the areas of AI, machine learning, and the initiative will start to basically provide an education and to share knowledge around artificial intelligence that is accessible to all people around the world. And also the idea is to make it basically free to all these people as well, so that anybody can attend and anybody can learn. So, and to make there be as little barriers to this education as possible. And it's a worldwide community. Bringing the map up right now will take maybe a moment, but basically there are people all around, there's ones all around the world. There's a ton in the US right now popping up. There's ones there's a bunch in Europe. There's a ton in places like India. And these meetups are starting to come up all around the world. And this initiative was just started about a month or two ago. So it's all fairly, it's all fairly new, but it's growing really fast, and there's meetups happening all around the world. So there's a couple we'll start with the 7 values of the School of AI. So basically that's, the first value is embrace the weird. So embrace the weird basically means that we like to experiment, we like to think of crazy things, and basically the idea is that with radical experiments, they can lead to radical improvements. So we're not afraid of kind of delving into new territories and kind of exploring. So the second is obviously inspire and educate. That's the goal of School of AI, is to show people what is possible with all of these technologies, and also to basically give them the tools that they need in order to tackle all these problems out in the world that are possible to be solved. The third is data-driven optimism. So with the school, we've noticed in the news, you're always getting these bad news. It seems like the world might be on fire, but the data shows that we've been improving a lot. The average life expectancy all around the world has been increasing a great deal. Overall standards of living have been improving, and I think we have one more member coming in. Can you just open the door? Hi, welcome. So we're just getting started here. So the idea of the data-driven optimism for the 7 values of School of AI is that really our world is improving a lot, and we have the data. And our goal is to make sure that the trajectory keeps going upward and we keep making the world a better place. The fourth is rapid experimentation. We believe that everybody can make a difference, and they can make it fairly quickly. You don't need to necessarily be studying for 10, 20 years and then finally be able to make an impact. The way AI has been kind of democratized is that everybody can now have access to it, and everybody can run experiments with it and discover new things. And some things that have been fairly recently figured out seem just so simple and obvious, but just nobody else just thought to try it out before, and now it's kind of improving the groundbreaking research. The fifth is be frugal. We try to basically make sure that it's part of the goal of making this available to everybody, and it's that we want to make sure things are trying to be inexpensive, and so that everybody can work on this without needing, state-of-the-art computing lab, so that you can just you can run experiments just off your laptop at home. The sixth is choose love, not fear. That one is related to a couple of different things. One area is that there's been a lot of things going around AI, and some people are very very cautious of it. Well, obviously things like Elon Musk is obviously always warning people against the dangers of AI, and while it is something that can be potentially dangerous, we have to realize that AI in the end is a tool for us that we're developing, and there's a whole other like discussion on if it ever achieves general intelligence, but right now it's up to us how we use it, and if we are people with good intentions, and we make sure that we're the leaders and that we are the leaders in AI, we can make sure that the right people are the ones pushing this field forward. And then the last one is draw the owl. It came from this kind of joke of like, you start how to draw an owl. You start with like a circle and the base of the owl, and then you just draw the whole owl. And the joke around that is that you don't know all the steps in between. You don't know all the steps in between, but you kind of figure out the steps as you need to go along. So that is to say that getting an education in fields like AI is important, but it's also possible to achieve that in many different pathways. And one is by experimenting yourself and figuring out the steps as you're going along. So I want to get kind of like a raise of hands of how experienced everyone is here. Who is like hasn't really touched AI, just heard about it? Like, just raise your hands. Just heard a little bit about it. Okay, who's like worked with it somewhat, like use it maybe in a project, and who's done like can you just open the door? Maybe just leave the door open. Oh, welcome. So we're just going through. We just went quickly through the kind of what is School of AI, which is a global trying to spread AI education. We went through kind of the 7 values, and now we're on to just getting an idea of how experienced everybody is here. I'll be sharing all these slides online afterwards, so you can, and if anything that you missed on, it'll be easy to catch up. So, and who's kind of had a lot of experience with AI? Like either it's done a lot of research in the field or done a lot of work with it, considering themselves like intermediate or above. Yeah. Yeah, awesome. Awesome. All right, welcome. So we just went through a couple of things like what is School of AI, 7 values, and I'll be sharing all these slides online afterwards. You can just take a seat. So why study AI? Well, it's really cool. Like there's so many things being done out there, from winning at many games to medical applications, everything else. So really, we can solve immensely complex problems, and often without necessarily. And that's where we can surpass human capabilities. Where in areas such as certain areas of language translation, image recognition, it has been shown that these algorithms have had a better accuracy than like the top humans in those fields, and which can also be shown as an example in things like playing chess, for example, or even the latest game of Go, the game of Go, where DeepMind's AlphaGo has surpassed like the world kind of champions. And has beaten them many times. So we'll start. I think a good area is one of the really hot areas in artificial intelligence is neural networks. So I want to give kind of everybody a very kind of top level overview of what neural networks are, how they work, and then show you and then give you kind of a demo afterwards of how deep neural networks can be used very quickly and trained quite easily without having too much in-depth knowledge of them. But then if you have that in-depth knowledge, you can further customize them and improve them and really take them to the next level. So we'll start off with just types of learning. So in general machine learning, we have a couple of different types. We have a couple of different goals when we're trying to make our model learn how to do something. One idea is that when we have supervised learning, the idea is that you have your data, for example, we're trying to predict house prices, and where the house is located, the square footage of the house, if it's like what type of neighborhood is, what maybe like special buildings are nearby, is there a mall, a school close by, and other information, and that will be your input data. And then you want to predict how much does the house cost, right? So the model aims to learn basically a mapping from all these features at what we call features X, or the input, to the output, which is the price. So then the other type of learning is unsupervised learning. The idea is that you don't know what the labels are ahead of time. So you just have a bunch of data, but you don't know what you're predicting on it, what the patterns are, but you want to find patterns in the data that you have. So like this is an image I think that like illustrates pretty well the differences. You can see in supervised learning here, we have like these O's and the X's, right? And we already know that those are O's and those are X's, and we just want to draw a line that separates where are the O's and where are the X's. And that's an example of supervised learning. We want to create a boundary. And then unsupervised learning is the idea that you want to find all of these right now are just O's, but we want to find a pattern, and a very common thing to find is basically clustering your data. So we can see that there's a cluster over here, a cluster over there, and another one over here, and that's kind of the difference between them. And then there's also like the like semi-supervised learning, where like you basically have a ton of data, some of it labeled, some of it not, and then there's some kind of tricks to figure out, can you like extrapolate those labels to like the rest of your data and in what ways. And that's something that we'll go over like in the future. But right now we want to just go over what is a neural network in general. So a lot of people are probably like a little bit at least familiar with how the brain works, and this is what it is heavily obviously inspired by, hence the name. So the key here is you have neurons, which are these circles over here, and I'll have a larger image afterwards, and synapses, or connections, which is what connects these neurons all together. So the idea is that you want to take some input given over here, and given the input, like again with a house as example, you have like this one can be like your square footage. This can be like, is there a school nearby? And this one can be the like particular location, or like weather patterns. And you want to figure out, and the output is you want to know what's the price, what's going to be the price of this house. So the idea is that as you go through this network, you input all these values, and they flow through this network, through these connections that activate certain neurons. And as these connections flow through, it figures out the price. So how do we go about doing that? So this is on a very simple level of what does a neuron actually do. So we have some inputs here. This is we have some inputs here. For example, once again, it could be like location, footage, like etc. And then we have certain output coming out of here, out of this neuron. So the idea is that each connection, we give a certain weight to this value that comes through. So for example, the square footage could have like a very large impact on the price of the house. Maybe if it's the amount of rain, and maybe this is like how often does it rain. Maybe that doesn't have as much impact on how much the house itself costs. So we could have this connection having a really high weight, and this connection having a really low weight. And then that means in the end, when we come out here, we basically have an output of like in this case, it's just a 0 or 1. That's like the simplest case. So we just say, if we add up all these weights and it's greater than a certain threshold that we decide on, we just say this is 1. So this is a very simple model if it's like true or false. It's like should I go outside today? And maybe like, and if I'm to go inside the gate, it's like this could be like the weather. This could be like how I'm feeling today, and something else. For example, if like the weather's really bad, it could have a really high weight. I'm not going to go outside today, right? And that's how like a very kind of singled off like simple model works. So you basically take these and you connect them all together into a larger network that can make more complex decisions than just like a yes or a no. Yeah, a yes or a no. So when we go back to this image, the same idea kind of happens. Except here, instead of a single neuron, we have the idea that we have all these inputs just as we did before, but instead of being connected to just one, they're connected to many over here. And all of these, they repeat the same thing on multiple layers. And adding these additional layers is what allows the model to make more complex decisions and more accurately predict the function. Because really, what we're trying to do is there's some unknown to us function. Like say we're trying to predict like the pricing of houses, and they're just like going like based off some variables, and say it's just like square footage and like location, and just follows a certain path. We don't know what that function is, but this neural network basically tries to, as close as possible, approximate that function. So if you took a value from this neural network and you took a value from that function at the same spot, they would be about the same. Hi, welcome.
Hello, thank you.
So we're just going quickly, like the intuition behind like a neural network. I'll just do a quick kind of recap. So the idea is that we have these neurons, and they're connected together by synapses into this network. So then, on a very base level, we have our inputs, and each input has a certain weight. And because of that weight, that's what lets us decide what certain factors are important and what factors are not important. And then we can produce an output with our neuron. And based on that, and then this neuron can act as an input to the next layer. So once we hook those all together, we get something that looks like this, where we have all our inputs. They're connected to what we call hidden layers. Hidden layers are basically everything in between input and output. So we have our input. It feeds initially into our network, and then based off the weight of each one of these, this network decides, okay, so this one might be like more important, this one might be less important. But as we go further, start to become a little harder for a human to understand directly, because this neuron is really a combination of multiple input features over here. So you can't really say that this one neuron now represents like how important is it that it's rainy, because it's really a combination of multiple things here. So it becomes like harder, and that's why sometimes they call it like sometimes they call neural networks like a black box. Is that like looking at it's like you kind of have some stuff going on in there, but you're not sure like looking at the examining the specific weights doesn't always lead to very interesting like outcomes, because they might not make sense to a human necessarily. But in some cases they can, when looking at, for example, image recognition, because then you can see that certain neurons are specifically learned to detect edges, and then later on certain neurons figured out how to detect faces, for example, out of building up on previous layers. So how do we actually get this to predict something, right? Because in the end, we want to give it our inputs and figure out, okay, what's this house going to be worth? So you just pass in the inputs into the input layer, and then on each layer, we just follow this same. We kind of just repeat these steps kind of over and over again for each layer until we get to our output. The only like in networks, this step could be a little more like complicated because there can be certain rules. It's like the function that decides in here what the output will be can be a little more complicated than just like summing these, and it could have certain cutoffs. It's what's known as an activation function. We're not gonna go like too hard into the maths like this time, but I want to have people have some idea, and then they can like read deeper into it if they're interested. And I'll also be providing resources. There's, for example, something called like a square loss, where we kind of punish like things that are very far away, that are very wrong, but things that are kind of a little bit wrong, we don't worry as much, and that helps like decrease like outliers. And I'll add some links on that afterwards as well for all of you to, because loss is kind of finding the minimum. So we do need some basic, initial like calculus here, which is being able to take a derivative. And from like math class and things like that, the derivative basically gives you the rate of change, right? So it tells you how much are we changing. The most important things it tells us is just like, are we going at this point in the graph, are we increasing or are we decreasing? Which means now we know which way do we need to go to get to the bottom. I think there's one on the Hi.
Hi.
So we were just going over some of the basics of neural networks. I'll send all the slides afterwards so you can catch up on the previous steps. But right now you actually came at a pretty good time because we just started talking about stochastic gradient descent, which is something that's pretty important to neural networks. I'll just go over it quickly once more. So the idea is that you have a function, say just a simple parabola, and you're at some point on that function, and you want to get to the bottom. You want to find the bottom, without necessarily like knowing ahead of time. Like there are like analytical ways to find the minimum and maximum of a function, but it's like all you want to know is which way do I take a step on a function to get to the bottom. So here's kind of like an example of it is that we're starting like at this point over here, and we want to figure out which way do we need to go to get to this point, because we want to find this minimum. So, and that can be done really by, it's actually kind of a little hard to see because this is moving fast, but you can see the derivative here is negative. So we take a derivative at this point. That thing tells us the rate of change, and from that we know that we just need to step this way to come to the bottom, because as this x increases, we know the y value will decrease. So we can just take steps in this direction, signified by all these dots, and we'll eventually arrive at the bottom. And so, as an example, this here it's closer to actually showing like a loss function is that what this kind of graph on the right is showing is like we're trying to approximate this line over here, right? Which is like very common. This is like you could like linear regression, for example, which is like another kind of thing in machine learning. And we just want to draw one line that as closely as we can approximates all these. It's actually something that's used not just for neural nets, but in a ton of other machine learning. It's like one of the core things that you could have. There are some issues with it though. For example, here, you can get trapped. So the idea is that if I start over here, and we need to figure out, that did not come out too well, but we want to figure out a step that's way too big, so I take a step to the left, like say this much, and it actually makes it worse, because if I take a step, however much, it's like say like a step of like size 50 or something, and makes me end up over here, then I'm actually worse off. And you get into the situation where if your steps are too big, you're actually getting further and further away from the bottom. So there's a lot of kind of like fine-tuning involved into how do you get to this bottom, and how do you get to the top. And that's kind of like the issue. So the idea is that you have a function, say just a simple parabola, and you want to figure out which way do we need to go to get to the bottom. So and that can be done really by the derivative at this point. like for sure get to the bottom, but also quickly get to the bottom, because you don't want like you to be running your program for like days on end. So luckily with some of these, and a lot of it was a lot of the time it's a lot of kind of like intuition and fine tuning, and there's some generally like agreed upon values that kind of like work in like many cases. But then one thing that was like used and published in a paper maybe like about a year or a bit more ago is a simple thing, is just a learning rate finder. It's like it's a little bit of code that just before even running your whole network, actually running through all your gradient descent, trying to find the bottom, you run a bunch of quick samples to figure out what's the approximate learning rate I should be using. So then that eliminates having to hand tune this. So the idea is that you basically try a bunch. You start off with like some small learning rates or some big ones. So the idea is that you start from a low learning rate and you see how far can I push it before I start getting really bad results. And that's all this program does. Is it keeps saying, okay, if I increase it a little bit, do I still get like a kind of a good result? Okay, if I increase it a little bit more, and then it sees, okay, I've reached a point now where the learning rate where the error is starting to get really bad. I'm actually not, like, I'm starting to diverge from where I'm trying to go. And then you know, okay, that we've gone too far. Use something a little before this because it works. So it kind of, you can see it as an example here is like we have our loss here, which is what we've been trying to kind of optimize all along, because we want to figure out basically to get as little error as possible when making predictions. But then we have learning rate, and we keep kind of, this is actually like a negative, like 10 to the negative 5, 10 to the negative 4. So basically like it's a log scale, but basically as we're increasing our learning rate, we're noticing, okay, our loss is actually dropping. So this is a fast, but then we see, okay, we've gone too far. The loss has went like huge. So we can probably pick a point. This still requires some intuition, but like points around here like are pretty good to our, like learning rates around there are pretty good to pick, and like you're fine. And there's a really good article on this topic that I've linked here that like goes into more detail on how this actually works, how it's implemented, how you can use it. And so we have some more topics that I won't be covering over right now, and there's a whole, like, there's a lot deeper we can dive into just with like the idea behind neural nets and like the mathematics behind it. And I'll make sure to link resources to that for those that are interested. And there's a lot more topics we can cover, from deep neural nets to convolutional neural nets, which are very popular in image recognition. Other forms of supervised learning that don't even involve any sort of networks. Different types of optimizers, like, and much more. So I want to kind of go over now some exciting kind of developments in the field, and also do like a little bit of a demo of something that I think could be really useful for those of you that are interested in and have even a little bit of like coding like experience. It can be really useful for very quickly using and building out and improving deep neural nets, actually. Now this thing is called Fast AI, and it actually was like, it's both a course you can actually take online, but they also have built out a library. It's actually taught by the president of Kaggle. Kaggle is like an online kind of data science competition website that's become like very popular in data science community machine learning, and he actually teaches this course. So the idea behind it is that you want to train these world-class models, but really quickly in a couple of lines of code. But you can also dig deeper into the library to really customize certain pieces, and control the various variables and parameters that affect how the model works, and also work on actually building your own models as well. So it's great from like both beginners to experts. And there's the link to the course below. So we're gonna train a quick image classifier, and I'm gonna explain a couple of these topics very briefly around the learning rate finder we showed, transfer learning, saving models. We'll see if we cover those other topics down there.